Today, thank you to attend this session. My name is Lu Bin, and I'm from Arm. Today, I will do a brief introduction about the situation of gVisor container on Arm platform. Let's see the agenda. There are six parts of jobs in this session. Firstly, I will introduce something about the gVisor container. We will talk something about the background of gVisor container. What is gVisor? And next, I will introduce the architecture information about the gVisor container. Then, I will show some detailed information in the software of gVisor. And in the fourth part, I will show the situation of gVisor container on Arm platform, including what we have done and the next steps we need to do. And in the end, I will do a short demo for you. OK? Let me introduce something about gVisor container. Firstly, I think here, many people here already know about the Kata container. For Kata container, it's much like a virtual machine with OCI supported. For gVisor container, it also a solution for secure container. And also, the gVisor container support the OCI, so it means we can run Docker with gVisor container. But from the architectural side, the gVisor container is totally different with Kata. Basically, gVisor container is a user space kernel. It was developed by Google for more than 4 or maybe 5 years, and just open source in about 9 months ago. The gVisor container provides a container runtime. The name is runsc. And also, it's composed with OCI. Please see the picture in the right side. We can see the Sentry module inside the middle of gVisor. We should remember it. The Sentry module is the key feature of gVisor. This feature provides 2 functions. One is the user space kernel, and another is the isolation platform. For now, there are 2 isolation platforms in gVisor. One is ptrace platform, and another is KVM platform. So let me summarize this page. Please see the left side. gVisor container is a solution for secure container, and it is a user space kernel, which written in Go language, and it was developed by Google. Also, it supports OCI, so it means we can run Docker container with gVisor. Also, it provided 2 isolation platforms. One is ptrace, and another is KVM platform. So let me introduce something about the architecture of gVisor. Please see this page. It's the isolation architecture of gVisor container. Basically, gVisor is more lightweight than a virtual machine. But it can provide a same level of strong isolation as a virtual machine. Also, the memory footprint for a typical gVisor runtime is very small. As I know, it's smaller than Kata. So when we deploy gVisor in a typical Kubernetes cluster, we can get a better density, container density, and a better startup time. To ensure the security, gVisor container provides us. The key feature in gVisor is that it provides us a user space kernel and a strong isolation platform. One interesting feature is that the user space kernel in gVisor can simulate the Linux syscalls. Now, only about 70 syscalls can be executed in host Linux kernel. And this feature is implemented by Linux second feature. From the security side, gVisor considers these 70 syscalls are safe. And the other syscalls are implemented by the gVisor user space kernel. I think that the number is about more than 200. gVisor container can provide a strong isolation boundary by intercepting application syscalls and acting as a guest user space kernel. But the cost is, obviously, the intercepting syscalls need more computing resources. So it means more syscalls was called. More computing resource should be needed. So therefore, the performance of intercepting is a big issue for gVisor. Therefore, gVisor provides two isolation platforms. One is based on Linux ptrace sysemu. This platform, the performance of ptrace platform is not so good, but stable enough. Usually, we use ptrace platform to debug the user space kernel in gVisor, and always we can use ptrace platform to debug our container application. And another isolation platform, the name is KVM. The performance is quite good. So in my opinion, we can use the KVM platform is a better choice for production area. Now, we have enabled the ptrace platform on Arm platform. And we are trying to enable KVM on Arm. Please see the picture in the right side. The Sentry module includes two parts. One is a user space kernel, and another is the isolation platform. And the Go4 module is designed to respond for all the file system I/O operations to ensure the strong isolation. Please see the left side of this page. Let me summarize it. For gVisor container, the key feature is that gVisor can intercept application syscalls and exceptions and act as a guest user space kernel. The second is Go4 process is designed to handle all the file system I/O operations for security issue. And there are two syscall interception methods in gVisor. ptrace, the performance is not so good, but stable enough. KVM the performance is quite good for production area. And we have already enabled ptrace on Arm, and we try to enable KVM. Let's see this page. This page shows the architecture of ptrace platform. We have already enabled it. If we configure the ptrace platform as the default of gVisor, the gVisor application will use the Linux ptrace sysemu feature to intercept the syscall from the container application. When the container application is going to execute a syscall, it will actively stop, and then the user space kernel in the sentry will check the information from the general purpose register. Then the user space kernel will simulate the syscall in the user space. Please see maybe please see the origin boxes here. sysemu, second namespace. For ptrace platform, these three features in host Linux kernel should be enabled firstly. Okay, let's see the architecture of KVM platform. This page shows the architecture about the KVM. To get a better interception performance in bare metal, especially in bare metal, gVisor provided another interception platform. The name is KVM. Please see the picture in the right side. Basically, except for the KVM platform, the other modules are same with ptrace, the same user space kernel, and the same gVisor process. For KVM platform, gVisor added two features. One feature is a type 2 hypervisor in Linux host, and another is a small application in the kernel mode in KVM. This small application will configure the vector table, will configure the general purpose register and the control register. Also will configure the PC, SP, and so on. Now, this KVM platform is not ready on ARM. Okay, let's see the storage part of gVisor. For security issue, all file system operations are sent to a proxy. The name of proxy is gVisor. Also, we can see here, 9pfs. Now, gVisor uses the 9pfs to communicate between Sentry and gVisor. As we all know that the performance of 9pfs is not so good, both in Intel and ARM platform. So maybe this is an issue, a performance issue in gVisor. And later, maybe 9pfs will be replaced in the future. Okay, the summary of this page is that the gVisor module is designed to handle all I/O operations in gVisor for security issue. And the performance will be enhanced in the future. Okay, let's see the networking part. As we all know that gVisor is a user space kernel. So of course, a user space IP stack should be provided in the gVisor. And now this user space IP stack's name is NetStack. It's an open source project. The link is here. We can download it and check it. It was also written in Go language, and it was also designed by Google. As well, we all know if we want to deploy a second container in Kubernetes, at least two networking topologies should be supported. One is bridge networking. For bridge networking, gVisor has already supported 10 VTH device. So it means the gVisor can compatible with CNI, maybe Frano CNI. So we can deploy gVisor in Kubernetes with Frano CNI and so on. And another networking topology is pass-through. As we all know that the pass-through topology will get a best networking performance for a typical container runtime. So in Kubernetes, we can use SRRV CI to work with gVisor. So compared with CI, it's not a problem for gVisor. And one point is that the pass-through performance is very good for gVisor. Okay, let's see the software details in ptrace platform on ARM. In this page, please notice here, runsc. Runsc is the container runtime, is the name of the container runtime in gVisor. Basically, runsc is the further application of other processes in gVisor. This page shows the initialization step of runsc. And the main .go is the entry of the gVisor. And also please notice the red characters, ptrace, kernel, exec. If we want to port in the gVisor ptrace platform on ARM, we should enable them firstly. Such as we should add the architecture-specific code in these modules, such as to configure the register, to configure the memory layout, and so on. Let me introduce something about the central module. Central module, as I say, central module is the key feature of gVisor. We have already enabled, please see this page, the ptrace depends on so many modules, so it means we have already enabled these modules on ARM, such as stub, arc, kernel, memory, and so on. So here, let me do a brief introduction about the sentry process and the stub process. Basically, stub process is the further application of the container runtime. The container runtime, the container application maybe is a hello world container or a web server container. At first, the sentry process will create the stub process, and the stub process will create the container application process. And then the sentry process will attach to the stub process and the container application process by kernel ptrace sysemu feature. When the container application is going to execute the syscall, it will actively stop. Then the user space kernel will check the information of syscall and exception in general purpose register. On ARM platform, we will read the syscall number from X8 register, and then gVisor will simulate the syscall in the user space. Basically, the user space kernel will do a loop to detect and simulate the syscall and exceptions from the container application. Okay, let's see what we have done. Currently, we have enabled ptrace on ARM. So it means we can use ptrace platform to intercept syscall and exceptions on ARM and provide the user space kernel for Docker application. For this story, we rewrite several modules for ARM platform, such as arc, kernel, stub, and so on. Please see this picture. As you see, we can already run the hello world container on ARM platform. Please see, notice the runsc command in the picture. It means we run the Docker with runsc runtime. Maybe in the end, if the time is enough, I can show a quick demo for it. Let's see our next plan for gVisor on ARM. Our next step is to focus on the KVM platform for production area to get a better performance. When KVM platform was enabled, we will focus on the full syscall supported on ARM. Maybe we should support some big data container or maybe some web server container and so on. We also will refine our code, enable more syscalls, enable more Docker applications. Also, we will try to improve the performance for ARM platform. Maybe networking or maybe storage. Demo. OK, let me show a demo for you. OK, firstly, let me. OK. Firstly, let me check the architecture of this server. Yeah, it's an ARM server. To use gVisor with Docker, we must add the runsc as a default runtime to our Docker configuration. The file is here. Please notice this line, this command. We should add the runsc here. Also, if you want to enable debug logging, we should add the runtime orgs here. This means we enabled the debug logging. If this file was changed, maybe we should restart the Docker daemon after making changes to this file. We can use syscontrol to restart the Docker. OK? Finally, let's run a hello world. The runtime is runsc. Here, we can see the runtime is runsc, and the output is good. Seems good, so it works. Another tip is that if we want to enable KVM platform, we should change this line. Currently, we use the ptrace as a default isolation platform here. When the KVM platform was enabled, KVM can be configured here. Also, for this demo, I used the host networking topology. OK? OK? So, any questions? OK. Perfect.
I have one.
Oh.
So for the ptrace, the kernel basically controls the parent of the process, and then you can intercept the syscall. How does it work, the thread for KVM? Do you know?
Yeah, currently we try to enable KVM platform, and we know and in Intel, we have investigated the KVM platform in Intel platform. Just like in this page, there are several key features in KVM platform. The name is maybe blue pill and red pill. It's much like the concept, much like a rootkit. Do you know the rootkit? Yeah. So in Intel platform, top 2 hypervisor in host and a small application in KVM in kernel mode to configure, configure vector table in Arm platform.
I see.
Yeah.
So you can grow with the host. Okay.
Yeah. Okay.